let's take some time to specifically understand the numeric type classes in the hierarchy. We have a number of different types defined for us in the Haskell prelude for dealing with numbers. These include int, integer, float, double, which we have discussed before. Each of these types define instances for different type classes in the type hierarchy. All of them define instances for num. So let's see what that means exactly. Here is the definition of num as defined by GHC. There are a number of things I want to highlight about this definition. Firstly, if we look at the type hierarchy, we can see that the Haskell specification states that the num type class has a constraint. Any type which defines an instance of num should also define an instance of EQ and show. But in the definition we see here, there is no type class constraint present. Well, that is because the folks implementing the Glasgow Haskell compiler are being a bit cheeky, and since about 2012 have decided not to follow the specification completely. They have their reasons, and if you want to know more, you can check out the links in the footer. But if we look at EQ and show in the type class hierarchy, we can see that all types except IO and the weird arrow type which I said we can ignore define instances. So even though the type class constraint is not present in the type class definition, the types that implement the num type class also implement the EQ and show type classes. I'll show you how you can make the constraint explicit later in the module and effectively work around this, but for now, in most cases, we can just go ahead and act like the constraint is present. The second thing I want to highlight is related to the function specifications in the type class. We are only going to focus on the simple arithmetic functions here. If you want to find out more about the other functions, check out the documentation for the num type class. When you look at the simple arithmetic functions, you see addition, subtraction, and multiplication. Where exactly is division, and why is it not here? Let's suppose that num did have a divide function specified, just like it does for addition, subtraction, and multiplication. Well then, the type signature would be specified like this. And when we define our instances for the different numeric types, it would change to be like this. So for the float instance, we would take two floats, divide the first by the second, and return a float, containing the result. Nothing wrong here, everything would work as we would expect it to. We have the same situation for the instance for the double. We take two doubles and return a double result. Again, nothing wrong here. But what happens when we look at what the int and integer type signatures would be for their instances? Suppose we divide 1 by 2. Now the result is a half, which is obviously a fraction. This can be represented by a float or a double, but how would we represent a half using an int or an integer type? Well, you can't. The only way to always be able to return an int or an integer when doing division is to perform some sort of rounding, and it is not always clear what type of rounding would be best. So rather than answer that question, Haskell does not define divide for the num class. Instead, if you want to perform integer division, Haskell provides explicit functions which perform different types of rounding. Haskell actually defines the division function in the fractional type class, for which only float and double define instances, like you would expect. If you want to read more about the other functions in the type class, check out the documentation link in the footer. If you remember, in one of the initial modules, when we were just learning about Haskell types, I showed you this simple piece of code, which fails to compile and produces an error. At the time, I said we should just stick to using doubles for division, and that you would not be able to understand the error message until we covered type classes. Well, now that we have covered type classes and understood the type hierarchy, this error message should also be understandable. Divide is defined on the fractional type class, for which only float and double define instances. So when we provide an int, like what we are doing here, we get the error message, saying that there is no instance defined for the fractional type class for int. So we've come a long way since the beginning of our Haskell journey to be able to understand what was previously a very cryptic error message. If you actually want to do integer division, you can use the div function. Div has the polymorphic type signature of taking two values of type A and returning a value of type A, with A being constrained to types which define an integral type class instance. We know that int and integer have instances of integral, and so we can pass these types as arguments to the div function. The div function performs integer division truncated to negative infinity, so we get the result of 0, which is expected. This video is a clip from a longer video for beginners starting with Haskell. Check that out if you would like to see all of the content. Also check out the entire Introduction to Functional Programming with Haskell course on the Liger Learn channel. See you next time.